Hello everyone, and welcome to my new podcast mini-series, A Penny for Your Thoughts on Sustainability. I have guests from all over the world and we'll be talking about their thoughts on sustainability and how they do their part to make the world a greener place. Thank you for joining me today, Jon. It's great to have you on as a guest on this podcast. It's a new sort of detailed topic for me. My previous podcasts have been a bit more general, so I'm keen to sort of focus more in on the sustainability issues that we're all facing on the planet at the moment. So, yeah, thanks very much for your time talking to me this morning. If you wouldn't mind quickly running through your introduction, who you are, what you do, what your background is when it comes to sustainability, then we'll start running through and see where the conversation goes. Thanks a bit.
Sure. Yeah. No, thank you. Yeah, thanks for having me on the show. So, I'm Jon Davies. I've just recently restarted at Proclima, New Zealand, and I'm in an education and technical role there. And I've just left 4 years of working with Oculus Architectural Engineering. So that's the last 4 years. Prior to that, I was actually with Proclima again for several years, and the pathway to get there was kind of, I don't know, from my view, sort of interesting, a little bit of a bumpy road on the way into the industry. So I came out of teaching. I was a primary school teacher, ended up in building, so building as an adult apprentice, enjoyed 4 years doing that, and then ended up in procurement, at which point I was analysing products and working out what to do with particular products, including some of the Proclima products. So they came across my desk. So at that point, I stepped out of the procurement and into working for Proclima. So that was in the early days, the business startup, which is, I think, more than 15 years ago already.
Yeah. Time flies, mate.
Oh, yeah, it sure does. Sure does. And at the time, it was very, very challenging in the industry to be talking about sustainability from the perspective of building performance. So we still are all about the building envelope and the way that improving the performance of the envelope can improve, health and comfort of occupants. But when you get into the sustainability line, that's not really about health and comfort, although you might argue that health is sustainability in a way.
Well, yeah, there's the aspect around health of how much it's actually costing the economy by building buildings badly.
Yes.
There's that whole discussion there to be had as well, I think. So, yeah, it's part of the whole thing, for sure.
Yeah, absolutely. Yep. And I was just thinking, sort of tongue-in-cheek about the longevity of the occupants, not just longevity of the building. So there's some, obviously, all of these things are connected, well connected. And then, out of that, where do we get to there? So
You're with Proclima?
Yeah, so with that, in the last few years then, Proclima and then out to Oculus for 4 years, and that was a real broadening of an understanding around the envelope, sort of into different products, into different performance requirements for different purposes in different buildings, and sort of a broader sweep across the industry. So that was a really, really interesting time. During that time, I did a Master of Architecture by project through Unitec, and that's really what the focus of today is, around the Parker app. So we'll get into that in a wee bit. I'm sure you've got some questions on that. And so during that time, we were setting up a test rig, a test facility, which is called Shelby Wright Test Labs. Shelby Wright, that was a bit of a dig at the, doesn't matter what you do, Shelby Wright, just give it a crack. So Shelby Wright Test Labs, and that's now an IANZ accredited lab for facade testing. So we built a big steel box that you put a wall or a roof structure into, window testing. Inside that box, we would create a storm. So if you're familiar with the NZS 4284 type of testing, that's wind, water, and seismic as required. That was in use, or that was built while I was doing my research, and then I used that. So it just so happened to coincide with COVID. We couldn't have clients in the building, but I could work there. So I worked in there, built a wall to replicate a 1940s bungalow wall, timber window, timber weatherboards, no insulation. And I looked at how that performed, and I racked it. I moved that, I thrashed it with the seismic actuator, tested it again, wind and water, and it did really well. So we'll talk about that in a bit more detail and why I was doing that. But it just so happened that it coincided very, very nicely with COVID, and it allowed me a whole heap of time to work on that, to build, to test, to build, to test, and write a thesis around that. So that was completed at the end of 2021. We have that test rig is operational now, and we'll do some further testing in that. And we've been out of that research came a window system system. So the Stark window system, which is called their ambience inline window system, sort of fell out of that research and then was developed further to the commercially available suite, so with the UPVC windows. So yeah, I guess broad brush, my view on sustainability is around energy. That would be the kind of the primary focus, if you like. If we can improve building envelope, we improve the sustainable use of energy. And I say that because I've just used the word or the phrase, whatever, the letters UPVC. Well, some people push back on that and say you can't talk about sustainability in UPVC in the same sentence because it's a petroleum-based product. It's a plastic essentially. And I push back on that and I say, well, actually, that's a very narrow view on sustainability. There are lots of things that aren't incredibly sustainable, but when you put them together in particular use cases, they can be very, very useful.
And it does, a lot of that's a balance around how long the product's going to last. If you like, single-use plastic bags are a bad use of PV or plastic. But if you put in a window system in that's going to last 50 years, that's not actually that bad a use. If you look at it in terms of the carbon, embedded carbon in that window, it's a much smaller number over its life than a single-use plastic bag.
That's right.
And getting that balance right is important.
Yep. Now, there's one more aspect to that, which I think is the critical part, and that is the energy use of the in-use. So not just the embodied, but the operational.
The energy savings you get.
Yep. So if you look at a product and combination of products, because it always is a combination of products, and you look at how that level of performance affects that building for its use case, whether it's a single family residential or an apartment or a retirement village, there's just so many different use cases. Schools are another one where the considerations around how that's going to be used affects the materials choice and then should affect your choice of materials for the combination of materials in that envelope. And then, of course, climate plays into that as well. So we've just gone UPVC to energy to use case to climate. All of these things are connected, and that's the fun part of it. That's why I love what I do, trying to connect the dots sensibly.
That's one of the things that I think that I learned quite early on in my career as a building services engineer, is that designing a building it requires everything to work together. That if you design each element of the building on its own, you're going to end up with a building that's inefficient and is effectively fighting itself, because the windows and the facade impact on what you do with your lighting, the impact on what you do with your ventilation, the impact on what you do with your heating and cooling, and all of those things are interconnected. And if you don't treat the building as a whole, as a single entity, then you're starting out in a position where you're probably going to fail. What frustrates me most about working in New Zealand, I have to say, is it's a very siloed way of doing design a lot of the time.
Absolutely. Yep.
The architect does the facade and the windows, and the structural engineer does the structure, and the services engineer does the stuff inside the building, and we don't care how they interact with one another. Other than the basic coordination, the rest of it is kind of lost in the mix, which is, it's a missed opportunity every time.
Yeah, and look, that's why I quite like the passive house planning package. And, as soon as people hear passive house, some people switch off and they say, too hard, too big, let's do something else.
Too expensive.
Possibly too expensive. But the point there is that modeling tool, that energy modeling tool, takes into account everything that you just described. It's the whole, window size and the way that the windows are installed and the way that is, which direction that is facing and what shading is on that.
Building
and
orientation, etc.
When you put all of those things together using that tool, it doesn't have to be a passive house. I've just modeled I don't use that tool directly, but I've just had my own home modeled, and it is terrible. It is performing terribly. It's a 1939 Art Deco misery box, no insulation, single glazed aluminium windows. But I've used the modeling tool, passive house planning package, to tell me how bad it is. I know that it's really bad, but if I have a number on that, I have a gauge of what it's doing and then plan
see how
what
you
to
improve
do with it. Yep. So I think that's the exciting part. But
going
back to
I wouldn't be too a 1939 house. My house was built in 2017. I doubt it is performing much better than yours.
That's a little bit scary.
It's cold in the winter and it's hot in the summer. Poorly ventilated. We get condensation on all the windows when it's in the winter, and it's double glazed, but it's not thermally broken double glazing. The insulation is to minimum, and it's really not a very good house. It's way worse than anything that's built in the UK.
Sure.
By a margin, yeah.
Yep, sure. And I think this is our opportunity. So, yep, we get real frustrated with what we have built and what we continue to build. And in the middle of that, in the last few decades, we've built plenty of leaky buildings. That's another challenge. We'd look at that and say, well, sure, you've got leaks coming from the outside, and I've worked on some of those houses. It's very clearly from the outside, but equally so, we've got moisture accumulation from the inside that we're not really looking at carefully enough, not taking. So I heard a great quote the other day, read a great quote. It was no insulation before ventilation. And I'm claiming that now as something that I'm going to start using. I won't claim it as my own, but I'm going to claim it and use it. No insulation without ventilation. And I think that's the key bit that we're missing. We talk a lot about about insulation. We talk a lot about, and we are, new H1 rules coming in, or have already come in. But what we don't have in that mix is a mandatory ventilation rate for whole house ventilation. Now, I have opinion on what type of ventilation that should be, but actually at the end of the day, ventilation is good. I'm a huge, not detractor, but I'm anti-positive pressure systems, especially in new builds for our construction type. But other than that, even a negative pressure ventilation is better than no ventilation. So positive pressure is bad, negative pressure okay, balanced pressure mechanical ventilation system absolutely much every day, much better, because it's controlled, and you've got every room in the home that is actually being affected by that system.
I've found over my career that people focus on natural ventilation as being really energy efficient and not really understanding the implications of a natural ventilation system, in that it's uncontrolled, that you don't have any control over not only what amount of air is coming in, but what air's bringing in with it. And
so I'm intrigued. I'm intrigued by that. What do you mean by energy efficient? Because I can't see any energy efficiency in
there isn't.
that.
There isn't. It's a misnomer. There's been a fashion trend. Like if you look at schools, for example, schools until very recently were focusing on having operable windows rather than ventilation, because it was more energy efficient and cheaper and better. But there's enough studies around now that show that actually mechanically ventilating a space is much more energy efficient. It's much better control, and you get much better ventilation across the space than you do by just opening a window. But there is a misunderstanding that by a lot of clients and others in the industry, that by going with a operable window, you're going to have a lower energy system, because they don't understand the implications of having an operable window. And it's an education piece. I think you talk in your little bio about education of clients and others in the industry, and I think that's the biggest part about sustainability, is educating people as to what sustainability really means and what energy use there is in a building with different systems, so you can make an informed judgment as to what's the best solution, rather than going with what feels like it should be low energy because that's what you've been told in the past. And that whole education piece is a bit, I think, we're missing at the moment over here. Not so much elsewhere in the world. I think there's a bit more understanding, certainly in Europe and the US, about the building design. But I think there's a bit of an education gap here at the moment. Certainly when you look at the regulations, the code, building code is terrible. And, there's a lot of industry pushback.
Yeah. And it's the building code is terrible statement is interesting too, because I quite like our building code, but for some rather interesting reasons, I think it has some really good wording. E2 as a classic. You can't actually fault E2. It says if water gets in, make sure it can get back out. When it gets in, make sure it can get back out. Well, you can't do better than that. Ultimately, the performance clause in there is prevent accumulation of external moisture. That's a good thing. You can't do better than E2. So I quite like that. But I think what you're referring to is the kind of at the acceptable solutions end, where it says, you can do this much heating, but you don't actually have to, except for early childhood centres and aged care facility. So that's where it comes undone. I think the
insulation standards as well. I think H1 is terrible, but that's slowly improving, but not enough.
But again, H1 talks talks high level about being able to control your environment or use. So when you get into the prescriptive parts of that, which is not the broader code clauses, that's when we come undone. But
Yeah.
again, we all know that that is the minimum. It's a minimum level of insulation, but there's no requirement for performance there, right? Like there's no connected dot between, hey, I'm asking you to put, well, I mean, at the moment, R6.6 in a roof, but actually, what do I need it to perform as? What's the, there's that missing gap in there. I think it's a challenge.
I think one of the things that we should be focusing on is setting a template for energy use in buildings of different types and overall energy use on a watts per square metre basis, which is what they do in the UK, to achieve a standard. Then the insulation becomes part of the solution. It's not you need to put in R6.6. It's you need to put in what's required to achieve this energy footprint.
That's right.
And that's where it comes back to your earlier point that it really, sustainability is about energy, and it's about how you use energy across the building life, and what systems you put in. But all of that is, you've got to look at the whole thing. You can't just look at what heating and cooling system I'm putting in. You've got to look at the facade. You've got to look at the roof. You've got to look at the glazing. You've got to look at the ventilation. All of those things all form part of that whole. And, the sooner we get that holistic approach to the design of buildings, the better, really, I think.
Yeah, agreed. I've talked before about our home being modelled in PHPP. The amount of energy required to keep our building at 20 degrees is quite astonishing. It's in the realm of, I think, $11,000 per year of an electrical consumption to do that.
Yep.
And that's not all year. That's essentially winter. And I'm Auckland, so Auckland is not ridiculously cold. So it's a short winter, and it would still cost us, if we tried to heat every room in the home to 20 degrees, it would still cost us around $11,000 per year.
Yep.
So what we are working on with that is then a retrofit insulation and ventilation and improving or changing out the windows to improve the building envelope as a whole.
Yep.
So we're doing that carefully, and that's based on my research or sort of springboarding out of that. But prior to getting to our home, we've got another project which we're just about to do, and that is for the ARA Charitable Trust out at Auckland Airport. And that home, we've taken a kainga ora state house, and we've been gifted 5 of those, or at least the ARA Charitable Trust has been gifted 5 of those. They've been cut off their foundations, transported to their site, and they bring in students from around the local schools, senior students, and they work on those homes. And it's not really about learning to be a carpenter, it's about a broader brush of skills there. So the outcome of the homes is not super high, but then that's not what they're there for. But we've taken one of those homes and we've said, okay, we're going to apply my research, which was called the Parker App, and we're applying that to that building. And we're looking at the walls predominantly, so that's the main area of change. We've got insulation in the ceiling, we've got insulation underfloor. What do we do with the walls and the windows? And I'm just going to put my mic on mute and cough. And now I'm feeling much better. So what we're doing there is we've modelled that home. And so Joe Lythe from Respond Architects has taken that home, we've measured up, and we've modelled that, and we've put that into, again, that Passive House planning package, Excel spreadsheet, energy modelling tool. And what it was doing was, and again, if you're trying to heat to 20 degrees for every room in the building, that was going to require 167 kilowatt hours per square metre per annum to keep that home at 20 degrees. Now, that's just a number, and it's hard to put dollar figures around that, but 167.7. By putting our Parker App system, which is a retrofit solution of wrapping the existing building with insulation on the outside and changing out the windows, and we'll talk more in detail about that if need be. By doing that, in our case, we've only used 50 mil of insulation, of an external insulation, rock wool. We've put 50 mil on the outside of the walls, and we've changed that energy consumption modelled from 167.7 down to 30, just by adding 50 mil of insulation as a continuous blanket on the outside of the wall. Now, that's the current modelling. Again, that's what Joe Lythe has done at Respond. And we've done a similar thing to our home, and the numbers are quite different. The numbers started much higher and ended up a little bit lower because we're putting a bit more insulation onto our walls. So that is essentially the Parker App. It's a different way of approaching a retrofit solution. So the current typical retrofit is either take off the cladding and work from the outside, put insulation into the wall between the framing, and then reclad, or working from the inside, take off the internal lining and putting insulation into the wall, putting the linings back on. Now, both of those options have their merits. Both of those options are costly. The Parker wrap is not cheap, but it achieves something a little bit different to what you achieve if you put insulation into a wall cavity.
Have you done any modelling of the sort of the whole of life cost of the Parker wrap system? What's the how long does it take to pay back on that building, for example? Would it, in terms of energy savings, if you're saying that you're reducing your energy required, take your house for an example, if you're reducing your energy required by about 70%, your bill of $11,000 for a year becomes around about $3,000. So, what's the cost of the Parker wrap? How long is it going to take to pay back? Because that's a sort of a one-use thing you put it on, and it's got a 30-year life.
Yeah, well, there's no. Yeah, so the first answer to your question is no. I haven't gone down that path of looking at a payback period. I take Ian Mays, who's an eco-design advisor in Hamilton, I think he's based. He said a payback period is better than no payback period, meaning do something to improve it in some way. So that's the first starting point there, and I think that's really important because the benefit of doing this is not just in saving some money on energy, because if you do, let's put a dollar figure on it. Let's say I'm going to do $120,000 worth of work on my home, which is not unrealistic in that I'm changing out all of my windows to UPVC double glazed, and I'm it's an extensive. Well, it's not that extensive. It's a substantial piece of work. We're over cladding. We're over sailing the building with insulation, and then over cladding that at the end. So I end up with a very, very different building envelope in terms of its performance. But I get that on day one. And then I look at that across the health costs of the family and the comfort level, and the longevity of the envelope, of course, is important too. The cladding choice is going to be, that's going to influence the durability and the lifespan of that whole structure. So I'm not trying to sell this I'm not trying to sell it to you, but I'm not trying to sell this as a save energy thing. If you think about this, let's go way back outside this. If I improve any building and I make it possible for you to heat, then it's going to actually cost you more money to heat compared to not heating at all. So currently in our home, I can model, our last energy bill was over $600. That's because we've tried for the coldest bits of winter to keep 3 bedrooms warm and to keep a lounge area warm. Now that has made some impact, but it's our windows, you can see out the frame. So we're losing everything we put in almost instantly. And this is the key bit. You heat inside a home, you lose it all. Even the best performing homes, you lose it all eventually, but it's that speed of loss and that we're trying to slow down. So right now, we're losing everything really, really quickly. Our energy bill is really high. Comfort levels are only moderate because we're losing all of the energy so fast. If it's windy outside, it's windy inside. Lots of people live like this, right? We're not talking about an unusual situation.
I've had similar comments on posts I've made on LinkedIn about people, when you just put a jumper on, and it's just like, you really don't understand the issue that we're talking about here. When we're talking about healthy home, a home that isn't sealed from the outside is not a healthy home. And the people that's in it, my daughter's a great example. We moved to a house in Wellington when we first came over to New Zealand about 12 years ago now, and she'd never had asthma in her life. We lived in that house for 6 months. She's got asthma, and 10 years later, she's still got that asthma. And that was because the house we lived in was cold, damp, and mouldy.
Yes, and putting a jersey on is not actually going to fix that.
No, it's not. Absolutely not. No, that's part of the. I think that's part of the Shelby Wright attitude that we've got at the moment. That people don't really understand the implications of living in a house that's cold and damp. They just think, it's just cold. I'll put a jumper on, I'll be fine. Or I'll put an electric heater in the room, I'll be fine. And not really fully appreciating the impact on their health, the amount of time they have off sick with chest infections and breathing-related difficulties and that kind of stuff, and how much that's costing them, as well as the economy and all of those other impacts that are really hidden most of the time. And I think that, I've seen some information about the cost of poor quality housing. Let's just talk about housing, and it's in the billions of New Zealand dollars a year because of the lost time for work and stress on the health system and other things.
Yeah, well, so I can give you the number on that just in the respiratory healthcare.
Yep.
That is a $7 billion annual cost to the country.
Yep.
So that's not the lost time at work that you just mentioned.
Just the healthcare.
That's just the respiratory healthcare. So that's from Asthma New Zealand. So I did some work with Catherine Leitner on this area. Not that I was doing that research; it was just sort of bouncing out of that, and I've used that in my research to to provide some ammunition as to why we would do this.
Yep.
So I think this is it. So what you just mentioned there was, you'd put a heater on. When I looked at the starting point of this research, my target was social housing. And the reason for that is if you can target the worst quality buildings, not that they are automatically social housing, but if you can target areas where the fuel poverty that is defined, in fact it's a British standard if you like, or definition of that, meaning a particular amount of your income is spent on fuel to try and keep your house warm. So if you look at that and you say, well, okay, if we're in fuel poverty, we need to improve the building envelope to get people out of fuel poverty. Now in New Zealand it's very, very common to just not heat at all. Just don't bother, because like what we've just done, you get an enormous bill at the end of the month and you think, well, I can't afford to do that. I will stop paying that out of my own pocket, and nobody else is going to do that for you, except that, as you just described, the health outcome, the spiral down of health over time ends up costing the country, not an individual directly. So that's kind of very, very broad brush stuff. So what I'm saying is, if we improve the building envelope, firstly, it allows you to heat, but that has its own little challenge. If it allows you to heat, it suggests that you should heat. If you should heat, it's going to cost you money. Now, for you and me, we might be able to afford to do that, but if you can't, then we need to approach this differently. And I don't have a really great solution there, except for a landlord being able to look at, and I'm talking about social housing landlords,
so
being able to
effectively,
but being able to look at the cost of heating a home and knowing how much it should cost to heat that home and saying, okay, it's actually cheaper for us to pay for the heating of that home than it is for us to pay for the health outcome at the end of not heating that home. So I mean that's a little bit future. That's a much broader, and it's not a political thing. It might be about who's going to pay for that. Well, let's get some funding through government, but it shouldn't become a political.
If you were able
just because
to
we're about to have our elections, that's not. It's not about that.
It's not that. I mean, it is more of an altruistic thing, really. That it should be cross-party. Everyone should be working towards us having a healthier population, because it saves money in lots of different ways. You look at things like, if you've got kids and your kids are off sick, you could take time off sick to look after them. That's one part of it. If you look at the impact on productivity, that's another part of it. If you look at the impact on the health system itself, that's another part of it. I mean, the cost is enormous across the whole thing, and I think that's where that education piece comes in. It's not widely talked about, but what would be roughly, how many houses have we got in New Zealand? About 2.5 million houses.
A little less than that. Residential is about 1.9 million, and so the numbers are a little bit frightening around that. So if you work out, I mean, the numbers are already there. This is studies that have been done that I just incorporated into my research, but we've got 830. I'm going to give the right number here, 820, I think, thousand homes that are residential Tenancies Act compliant. Now, I'm joining a couple of dots there, but just bear with me for a moment. So 830,000 homes are tenanted, and that should mean that they are insulated floor and ceiling. So that's why that's relevant. And then for my research, it was really focused on that 830,000 homes, wrapping up the walls of those homes. So we've got insulation in the ceiling, we've got something in the floor if possible, and then we're looking at the walls. So Parker Wrap is really about the walls and windows. Now, that's 830,000 homes. There's another 720,000 homes that are owner-occupied that have no insulation at all. So there's this real I mean, that's like the numbers are
That's
absolutely
that's what is that? That's
crazy.
1.5 million out of the 1.9 million houses
Yep.
that probably aren't great.
Right now, then on top of that, you add in every home that's been built since 1978, 79, which was when our insulation standards for walls came in. So if a home was built sort of since 1979, 80, you will find insulation in the wall, but that does not mean that it's good or that it's working as it should. It just means that it might have some insulation in the wall. So it might have collapsed in the wall. It might have been very, very lightweight. Then you keep coming through the decades and you think, okay, let's look at a home that was built in 2000. Well, how well is that performing? What were the standards of insulation at the time? What was likely put in there as a percentage of wall in insulation? Then you think about the way in which we've installed windows for decades, really up until now, when we've suddenly this year we've had 4 of the main window manufacturers. So Stark, they really kicked that off, and so that's something I can put my hand up and say I was a part of. They sorted out their recessed window detail as a really robust weather-tight detail. Suddenly, based off the back of that, APL jumped in there.
Doesn't it worry you that
Altus,
we're talking about
FMI.
now?
Yes, I know. This is the point. This is my point. Up until now, we've had all of our windows, whether they're thermally broken or not, and I've installed thermally broken windows outside the building envelope to comply with E2AS1, and they're outside the insulation line. They're not connected. Therefore, they're not performing anything like what they should. If you've got plain aluminium windows installed in the last 30, 40, 50 years in your building, you know full well how cold they are in winter. So we've got this incredible history and it's just what it is. So if you look back, there were improvements along the way. Things did improve, but now we look at it and we say, crikey, we can do a lot better. The challenge is, are we? I mean, we're still doing E2AS1 details. E2AS1 details are still being designed in and are still being built in because that's what people know, and it's the easiest compliance pathway through council.
Exactly. That's where the pushback from industry is a frustration. Is that that's how we've always done it, and that's the way we're always going to do it. Is a really short-sighted view, and it's missing out. That's where we're missing on a lot of opportunities. I mean, I look around Christchurch, and Christchurch, has had a massive rebuild, and there was a great opportunity there to do things differently. How often do you get to rebuild a city? And we did some good stuff. We've done some good stuff for sure, but there was plenty of other opportunities that were missed because people didn't want to change things too much, because there's a risk that we won't understand how to do these new things and they may not work, and I think that there's sometimes a real reluctance to take that chance that maybe the industry will step up. I don't know whether it will or not, but I think we're in a position now, when you look at looking at the bigger picture, where we're at with global warming or climate change, whichever way you want to call it, we've got some major issues globally to resolve, and my fear is that places like New Zealand, we should be leading by example. We're a relatively small population. We've got relatively wealthy as a country. We could do some really good stuff, and we could be leading the way for other small countries. But there seems to be a bit of a see no evil, hear no evil approach of, we don't, we're only small, so what we do doesn't really matter. And in the reality is that other small countries follow the example of the ones they see around them. So if we set a good example, others are likely to follow it. And that global responsibility is something else I think we're missing at the moment.
It's a really good point. So I come back and I say, what do we do about it? What can I do about that? And one of those areas you mentioned before is around the education. And so there's a certified installer training program that we've run in the past, and we're just about to kick off again. So I've got opportunity, as I restart here at Proclima to sort of revisit what we've been looking at, what we've been teaching people for more than a decade now, really. And the reason I bring that up is when I talk to builders about what we can offer, it's not about building quality. I'm not looking at a builder's work, a carpenter's work, and saying, oh, well, you're not building very good quality. It's not about that. It's about those minor details, and I call them minor. They're actually significant impact, but they're small areas. They are the windows. How are we connecting our windows into a wall that is going to change the performance? Well, are we? Yes, good. That's fine. That's a great question. But how do we do that? So what I'm saying there is, it's not about the quality or what you can see. It's about the invisible. It's about the things that are then hidden. It's about the taping. It's about the connectedness of the insulation. Now, that's not a building quality, and I said that 3 times now, which is starting to get embarrassing. But it's a building understanding, and that's the difference between me trying to teach. I did 4 years of building as an apprentice. It does not make me an expert. I'm not a builder. It's not about me critiquing somebody's stunning carpentry work. It's not about that. It's not about finishing lines. It's what's behind the finishing lines. It's what's detailed in at the front end from the designer, yes, but it's how that's actually shown up or followed through rather on site, which will make the difference in the performance of the building, not in the quality of the building. I think that's a really important distinction, and it's something that I've only really just clicked onto in the last couple of weeks thinking this stuff through, which is kind of a little bit embarrassing that I've only just clicked onto that. I think we've sort of stood on our soapbox and said our building quality is rubbish and we can do better. Well, actually, sorry, I didn't mean to offend you with that. It wasn't the intent. It was let's build differently to build significantly better, even though, and here's the thing, it will look the same. It will look the same from the inside of the building. It's likely to look the same from outside of the building, but boy, that building envelope is going to be performing something crazy different.
I'd be very interested to actually do the passive house modeling on my house. A 2017 build, which is should be a good quality modern house, and see what the difference is between mine and what you've got for yours. And I do think it does come back to design standards should be focusing on energy use per square meter. What are we that gives you a more holistic view. If you're focusing on just what's the facade doing, or just what's the glazing doing, or just what's the ventilation doing, you may miss the bigger picture. If we can set a standard that says we want to achieve X watts per square meter energy for everything that's used in the building, how do we get there? And it is going to need every system to work together. It's going to need the building to work as a whole rather than as individual parts. And that might drive the change in standard that we need.
Well, we didn't actually talk before this podcast, but that's exactly where I see the need going as well. I'm looking at using a tool, and there's plenty of people, not just internationally, but there are plenty of people in New Zealand that know how to use PHPP. You don't even have to have it done here. You could go internationally and get somebody to model your home. What you need to do is give them the design, and then the as-built would be useful. So you take that model, it's built in SketchUp typically. SketchUp then has a plugin called Design PH that then looks at the size of the windows and the orientation of the walls and the climate that it sits in, and then it takes that and it gives you an energy consumption, as an approximate, or I'm going to say pretty close. It's taking into, you just need to take into account as much as, if not everything possible. And I think this is a little bit of a danger and an opportunity. We need to model accurately, which costs a little bit of money to do. But when you start with that number, and I'm going to take an absolute guess. I don't know what your house looks like. I don't know what exposure it has. I don't know how many stories it has or how many windows it has or what type of windows. But I'm going to take a guess that your home will be in that modeling, it will be consuming more than 80 kilowatts per square meter per annum.
I wouldn't be surprised.
Per square meter per annum.
I wouldn't be surprised at all, to be honest.
So that's just a guess, and that's based from a few things that I can imagine your home, as you've described it just in our discussion just now. So why do you need to know that? It's because that is effectively an energy performance certificate. That's shortened an EPC, but that's got to be based on a really accurate model. It can't be based on a whole bunch of guesswork, otherwise it means nothing. Then you can look at that and say, hey, the walls are actually not too bad, but the windows are terrible. if I spend $30,000 to change out my windows, I might be able to move that 80 kilowatt hours per square meter per annum to 25 or 35, and then you work out that whole cost benefit and work out whether it's worth it, not just for energy but for comfort and and the health outcome as well.
I mean, it's there's still a long way to go, I think, from where we're at right now to where we need to get to. We've talked a lot about what we think needs to happen. What do you think's actually standing in the way of us at the moment getting to where we need to get to? What do you think the biggest roadblocks are in New Zealand right now?
Well,
there's a question that's putting you on the spot.
Yeah, I'm not sure that there are any good reasons why. There's nothing that will stop a designer from, and I mean, look, I'm a fan of certified passive houses for all of the things we've talked about, not because it's certified passive house and it's a German energy, performance rating tool effectively and a build intent, not because of that, not because I work for a German company, it's because it's measurable. So there is nothing in the industry that's stopping a designer from picking up that tool and looking at that PHPP, the passive house planning package, and modeling their existing design. If they model their existing design just like you've talked about with your 2017 home, if you do that, you'll know what it is doing. You'll know what the occupant is going to need to do to keep that home at a reasonable temperature, at 20 degrees, 22 degrees, whatever you choose. There's nothing in the way of that. And so if we know what our buildings are doing, it's going to influence what our buildings are doing, right? If we know where they are, we'll be able to make some informed design decisions to improve. And it might be just the windows. It might be just that thing alone. Or sensibly, it would be the windows and the slab edge insulation, for example. Certainly, there's a ventilation requirement for every new build. We're putting insulation into our new builds, right? But no insulation without ventilation. It's an absolute no-brainer. It's not just a no-brainer because I'm saying that. It's a simple science experiment that we all do with homes that are not ventilated. We have petri dishes inside. We grow mold inside because we're not ventilating out occupant generated moisture or cooking generated moisture or showering generated, breathing, breathing, cooking, cleaning, all of those things. We're generating moisture inside our homes, and the newer the building is, the less likely you are to get, and the newer, I mean, from 80s onward, the less likely it is to be drafty enough to move moisture out. Well, drafty is terribly uncomfortable, so I'm not suggesting that is a good option at all. And that's not about opening windows or not, as we already talked about.
Exactly.
So what's in the way of us doing that? I think the fear of change, the anticipated cost premium of doing something better. Now that starts right back at code, but the acceptable solution around windows again. So if I'm designing and I go to E2AS1 and I drag and drop that detail into my plan set, that's free. It's free because I didn't need to do any work, and I know that council will accept it because it's the acceptable solution. But that's a crap outcome for the owner of that building for its lifetime, meaning the building's lifetime. It's a really, really poor outcome. So at the front end of that, you've got this fear of additional cost. Now, there might be an additional cost in the way that we install a window, but not really. It's the same window. It's installed differently, and there are really, I mean, there's some different techniques in there if you like, or some slightly different connected lines. There may be an additional line of tape right around the window. Maybe that's fractionally different, but the trade-off there is that you might take out, like instead of doing PF rod and foam, you might do a taped solution, like we have one with Proclima. It was done while I was away out of the company, which is VM2 tested as a taped air seal on the inside. That already exists. So you take out the cost of PF rod and foam and you put in a product which is actually airtight and watertight and windtight and doing that job. So let's call that cost neutral for a moment. But what it requires of the designer is to find that detail and use that detail and rely on that detail. And then the fear is, and I know this because I talk with designers about this, is that will be pushed back at council and it will cost them more time and money to answer that RFI to make a better building. Well, that might be true. I can't deny that. That's possibly true. But it's only true in some small councils now who haven't seen this approach or haven't
understood. And it's
understood.
only going to be true the first time.
That's right. That's right.
Once they understand the process, once they understand the technique, then it's easy. It's done.
Yep. And I'll put up my hand now and say, throw me the RFI and I'll answer it for you.
Yeah.
And it'll be a stock standard. You don't even need to do it. It won't even need to be a problem. VM2 testing as verification method 2. It means it's verified. It means the councils should accept it anyway. They can ask questions about it, and I can understand that. But man alive, it should not be in the way.
I guess that's another one of my frustrations. There's plenty of stuff we could be doing that we're just not. Not because it's difficult, not because there's something stopping it, because we're not.
Because we're not. Look, I'll point back, and I'm a fan of this window system because I helped develop it. But the Stark window system, UPVC, yes, all the way back to the beginning of the conversation about materials and all the rest of it, sustainability. But UPVC housed either in the frame, so a recessed window. Now, I tested this myself. If you know anything about window testing in a test booth and NZS 4211 testing and or 4284, so there's some very strong similarities. You're water testing, you're adding wind pressure to whatever you're testing, in this case a window. The typical testing is quite low pressure, meaning hundreds of pascals. At absolute maximum. I mean, the highest tested windows will be around the 750 pascals with water pressure. Now that's at the extreme wind pressure. Well, I tested the Stark window, which is the ambience inline window system, and yes, I'm promoting that, but you go and have a look at the details on their website. Stark with an E, STARKE.
I tell you what, if you send me all the links, I'll put the links in the podcast notes.
Well, ambience inline window system, that I tested that in the test booth to the required wind pressures, all hunky-dory, no problem, no leakage, dug it all open, had a look, no leakage, all the rest of it. Then we just started to ramp up the pressure, and we ramped up the pressure, and we ramped up the pressure until we were at 3,200 pascals. And this is using a Proclima tape as the air seal on the inside. And then I started to remove elements from the outside to make the system worse, to try to break it. So I'm removing, removing flashings. I mean, they've even got a flashing system, which is an extruded aluminium, which is outside the insulation line. It's tucked into the outer edge of the window so that it doesn't affect the thermal, or doesn't increase the thermal conductivity of the frame itself. So 3,200 pascals, and I stopped testing there because I had some other issues in the booth that I was starting to break, rather than breaking this window. So, can we have confidence in these systems? Yeah, we sure can. They're there. What's in the way of doing that? Nothing. Seriously, nothing. A recessed window, which has been tested to the nth degree, of an air seal system which has been tested, and that's just the window. It's about as easy as it could get, and that will make the most significant. The windows are the most are the worst bit of our building envelopes as far as performance goes,
and one of the easiest ones to fix.
Well, I might suggest that not so easy. I mean, easy, yes, but perceived difficult, perceived scary. We've failed bits and pieces in the past. We've tried to recess windows. We've got, leaking windows, aluminium windows, all the rest of it. Yes, it happened. Can we do better? Yes. There are now four offerings in the market.
My counter argument would be that there are many, many examples of recessed window installations globally that work very well. The fact that they're not being done over here doesn't mean they can't be done over here. And what my view on that is that there seems to sometimes be a reluctance to use something from overseas in New Zealand, that we want to fix it our own way and have our own solution. But I think we need to be part of the global community, really, and rely on tried and tested solutions from elsewhere. And it is an easy fix to fix the glazing installation or the window installation so that it doesn't leak. I mean, it sounds to me like, why aren't we doing that anyway? The very minimum you'd expect of your window is it's not going to let the weather in, wouldn't you?
Yeah. Well, that's a good expectation, but it's not reality.
No,
so
that's
the scariest
kind of my
part.
point. Yeah.
So
your building envelope's got one main purpose. That's to stop the weather getting inside.
Yeah,
basically
that's correct. But the weather is not just wind and water. No. It's temperature. And this is where, if you look at the E2AS1 detail, you can argue successfully that as a detail, it can keep the wind and water out. But you look at that from a thermal conductivity viewpoint, and then because of the thermal conductivity, the internal temperature of the aluminium and then the condensation on that aluminium. So we've it got moved, windows got moved outside the building envelope so that when they leaked, they were leaking outside the building envelope, and then they suddenly are horrible for thermal performance. So what I'm suggesting there is, yes, E2AS1 is still the acceptable solution, and when you look at, like, E2AS1 is a big document, it covers more than just windows, but I'm specifically talking about the window detailing that is shown in that document. Can we do better? Yes, we can. And, you talked about international products. Yes, international products. Yes, we've got plenty of them available, but I'm also going to point toward the locally available products as well that are tested, absolutely, that have met much higher standards of weather tightness. That are possible, that are meeting higher standards of weather tightness, if you like, higher wind pressures, higher water pressures, and we can do it. Like, the details are there. Start using them.
Exactly my point. I mean, it's what I was saying is that there's plenty of solutions that already exist that are well thought out, that are well tested, and will work in this country. And there are local ones and there's overseas ones as well. So there's plenty of information there that should make it an easy fix, but there is a real reluctance to fix it. Or appears to be. I may be speaking of a term here, but
I think one of the things there.
I
think there's a commercial reality there as well. You think about the prime die holders here that we have in New Zealand. They've been producing aluminium windows for a long, long time. So the reluctance to change to thermally broken, I can understand that. They've got to retool, they've got to rework, they've got to throw away other products, dyes. But so there's a reluctance to change, and I think we can all acknowledge that. We're all in that boat quite often with a lot of things. But one of the opportunities there. So here's something. You go back 5, 6, maybe even 7 years. All of the prime die holders, and so I know that APL and Altus, not quite so sure about FMI, but APL and Altus had 6, 7 years ago and still have UPVC offerings. So you've got the Commerling profile, and I think you've got the Aluplast profile. So they're German extruded, or German products being shipped here as lengths of material, and then they are cut, welded, assembled here. So that process is largely done here using imported materials. They've had those offerings but not been heavily promoting them. Now, that's really interesting to me, because those prime die holders, they are aluminium window manufacturers, knowing the limitations of aluminium as a material, even thermally broken aluminium as as the typical profiles, and then seeing the need to have an offering which is significantly better performance, being UPVC. So we've got the offerings. There are 4 companies at least using the Aluplast profile, Stark being one of them. There's some differences among the themes there around those profiles, but we've got way down into the detail of windows here,
which is an interesting conversation. I mean, it's part of the whole conversation, isn't it? And as you say, that the weakest part of most buildings is the window when it comes to energy. That's where you lose most of your energy. So if you get that bit right, you've immediately got a big benefit.
Well, so, and going back to your question then, what is in the way of us doing better? I think that's one area. would be windows and reluctance to change. The
Mhm.
other one would be in the legislation around performance and a measure of performance. So we don't need to have legislation to have a measure of performance. We already have that. We can use watts per square meter. We can use kilowatt hours per square meter per annum. I mean, they're all good. We kind of need to choose one. So I quite like, as we've said, as must be very, very clear, quite like the Passive House Performance or the Passive House Planning Package tool, because it's very, very accurate and can be used for any building. Doesn't need to
Yeah.
be a passive house. That's the key bit for me. But
Yeah.
it gives you a measure. When you have a measure, you know where you are. And you can then start the race, and it's a race to the bottom in the best sense. It's the race toward a
The
building
lowest
with the
energy.
low energy.
Yeah.
And yes, there are diminishing returns on things as you decrease the energy, or as you attempt to decrease the energy required to keep a building at 20 degrees. But
There's always a
we can-
balance, isn't it? There's a level of compromise everywhere you look in design, and that's what the design process is about. It's iterative. You start off with an ideal, and you end up with what the client needs and what achieves the best outcome.
Yeah.
And within the budget that's available, and the skill set that's available, and all those other factors that apply. But I think the key point there for me really is that we should be focusing at a much higher standard to start with, and maybe coming down from that standard. But if we set the bar too low, it's easy to achieve. We don't really stretch ourselves. We don't really improve things. And
that's yes. Okay, good. So the Green Building Council now has version 5 Homestar. That is a much more challenging performance-based measure, which I think is really, really good, and I applaud them for it. There's actually a need to understand what your details are doing within that standard. There's a need to understand how those windows are installed. That's really good. So if we want a target, then it's there. And yes, they've got some developers that are a little bit challenged by that, but what's wrong with that? I think it's your point. Let's stretch a little bit.
Be
but
challenged.
And allow that to actually be a valuable measure of increased performance. We're actually chasing something good, not trying to meet the minimum.
Yeah, one of the things I've seen that's had a really positive impact in the past is if you get the government, for example, saying we're not going to tenant space in a building unless its energy use is below X.
Yeah, love it.
That drives the market because they're usually the biggest tenancies, and they usually want the higher quality offices. So you're driving the top standard up, and other people will then follow suit. It certainly worked very well in the UK when they were trying to drive the standards up in the UK. That's exactly what they did. The government said, this is what we want. We want this kind of performance.
Right. And so let's look at a case study that has just been opened here quite recently. In Auckland, we've just opened 18 apartments. They were called Beta Ventura. So that's the name of the road that they're on, or Ventura. Beta Ave? Anyway, 18 apartments that are certified passive house. And that means that the energy consumption required is 15 kilowatt hours per square meter per annum or less. But that is social housing, that is government funded, that is, or through Kāinga Ora, but that is a test case for that standard. And because of the way that those buildings work, the input of energy is low, but the outcome of indoor air quality is really high. The expectation is there that it's high because those particular ones have a balanced pressure mechanical ventilation system, and they have a very, very small amount of heat required, tiny amount of heat required to maintain 20 degrees. So it's that sort of approach. So if we want top down from government, government buildings, senated buildings, yes, but bottom up also has some power. If we can build certified passive houses for social housing tenants, there's going to be very little excuse for developers not to be looking at minimum. Minimum's kind of the wrong word, but hey, why don't we build certified passive homes and look at the real cost of doing that? Because I can tell you, with the changes to the insulation standards for roofs, if you look at R6.6, which by the way has to be more than R6.6 insulation in a typical roof to achieve a construction R value of R6.6. The
Yep.
cost of that roof structure is now astronomical compared with where it was. That's if you follow the schedule method and you build to that. That's a really expensive way of building. And what I'm going to suggest is that if you take that building and you model it and you look at what's actually required for that building and in that roof structure, you'll end up with a lot less. And I'm going to state this, put me on the record, you will end up with a lot less than R6.6 required. Now, is that going to be 100% true? Maybe not for Antarctica, but certainly for the bulk of New Zealand. Maybe not Alexandra, maybe not Antarctica. But the point there is that if we put some time into the design and we improve the building envelope, we'll actually end up with at least a cost neutral kind of something in there in that ballpark, rather than just expensive buildings.
That's where I started off, I think, with this conversation, talking about designing the building holistically. If you only focus on one element, then you're going to get a distorted view of what you need to do. If you focus on the building as a whole and what do we need to do to achieve whatever the target is, and I don't think it needs to be our 6.6 insulation. I really do think it should be. It needs to bring the energy use in the building down to 30 kilowatt hours per square metre.
That's it. But you need to also name a modelling tool to get there. And it might be one or two or three or whatever that are accepted modelling tools. Then you need people who are capable of doing that. And I say that because you can put in lots of different things into lots of different software and get lots of different results. We all know that. So there needs to be some... Yep.
It's
or GIGO, if you want to be slightly more polite.
If you want to be slightly more, yes, or RIR, rubbish in, rubbish out. There's lots of different variations on it. But that is true. You need, but the point, I guess, the point really is that if you start focusing on designing buildings in a more holistic way, then the ability to achieve a target becomes much easier, because you're getting everything to work together rather than trying to get the heating system to work against the building to achieve an internal temperature when the building's just leaking energy straight out the facade. That's not a holistic approach. There's the idea of building a better building immediately has savings throughout, because if your building works better on its own, you need to put less energy in, you need to put less plant in, you've got smaller riser spaces, you've got smaller plant rooms. All of those things become a factor that a lot of the time we don't really talk about.
Yep. Now, look, you just used the words plant and risers and all this. But and I get that from a mechanical services, perspective, all of that complex. But let me give you something which is much easier to digest. But think about putting a solar panel on the roof.
Yeah.
So my building currently is consuming an astonishing amount of energy to be, somewhat trying to be warm inside. If I put a solar panel on the roof, it lowers my energy cost by a tiny bit, but it does not lower the consumption.
Yeah.
And so my take there is that we should be, and I'm not putting solar panels on, if I wanted to run my entire home off solar panels, I'd buy a few properties around me and put a solar farm up to be able to do it. So that's stupid, and I'm deliberately making that stupid. My better option is to decrease the demand first.
Absolutely,
so if I decrease the demand, and I've actually, funnily enough, I've got this written on my whiteboard just behind me. Pick one option. You either decrease energy consumption or you increase internal temp. Now, that's a slightly different angle on the same thing, but I'm either going to just pump in more energy, that's the increase internal temperature, or I'm going to decrease the energy consumption by improving the building envelope. Now, the first one is obviously the best, because if I improve, and improving means changing the windows, in my case, changing the windows, putting some insulation onto the walls.
I don't think it should be an either or. I think, you start off by reducing the energy required, and then you look at how you best supply that energy. And part of the issue around sustainability is also how we get the energy that we're using in the building. And I think that solar PV is a big part of how New Zealand is going to deliver the increase in electrical energy required because of all of the changes that are going on. Talk about EVs, for example, and the energy they need. If you reduce the energy your building needs to heat it and cool it and all the rest of it and light it and whatever else, you've got more capacity then to do the other stuff.
But that's the point, that you need to decrease the consumption of the building first before you add photovoltaics on your roof.
On the roof.
So don't add PVs first. It should actually be the last when you understand how much you require.
Yep.
And it
Yep.
might be how much does the building require and how much does it take to charge my EV overnight. So
Yep.
charge the car, heat the home, how much. Yeah, that's very much a last cab off the rank thing.
Yep.
Not as an afterthought, but based on
Get everything else right
the
first.
thinking, the design. Yeah.
Yeah.
Now look, that is a
totally
challenge for retrofit,
Yeah.
somewhat more than it is new build, but I think you've still got the cost element there. What am I trying to say there? The upfront cost is still a challenge, all of these things. And I'm just looking now at the market. We talked about 1.9 million existing homes.
Yep.
Those homes need help. Most of those homes will not be demolished to rebuild something better in their place. They need help. They need to be improved. And so that's, going back to the Parker app, that's why we're looking at this option of working on the outside of the building, leaving the tenants, leaving the occupants, leaving the owner inside the building. You don't need to move your furniture out, but you do need to replace the windows and then add insulation to the outside. So low disruption, low waste. So we're getting into all these sustainable, kind of the words in there. So waste minimization. You don't need to take the existing cladding off and pay somebody to take it off and put it in the skip bin. You do need to take out the windows and recycle what's there.
Yeah.
And then the energy reduction is there, and the lack of disruption to occupants is a key part of that process too.
Yeah.
So that's what I've been working on the last few years, and now we're just ramping up all of that work, which is really fun, a really good challenge to make a really good impact into those 1.9 million homes. Big task.
It's a big task. It is, and it's part of a much wider issue, I think, as well. And that we're part of the global community, and we do really need to do our part for the global community. And I think if we can lead the way in some small part with the quality of the housing we build for our people, then that's a really good outcome. I think we've been talking for an hour and 15 minutes now. We could probably talk for another hour at least, I think. But I'd like to call this to a close. So is there anything in closing, any closing thoughts that you have about this issue and you want to get across?
Oh, look, I think it's all hands to the pumps. I mean, you could claim that at any time in our history, but I look at what the challenges are that are in front of us.
Mm-hmm.
And it is actually about people. It's not about buildings. We improve the buildings so that people can live comfortably, live healthily inside them.
Yeah.
So it's all hands to the pump. That's the call. We've got a number of people that are working on this, and we've got a number of people who are really interested in using this.
Mm-hmm.
We just have to, in some cases, find the funding to do it. In some cases, use existing funding, using existing streams, and the demand across social housing is one. Schools are another.
Yeah.
Ministry of Defence is another. They've got a huge work stream. So we need people looking at this and saying, "Yep, there's a robust way of improving our buildings," and not a sticking plaster, but something which is a significant,
a long-term
measurable
solution.
Yep, long-term and measurable and predictable solution. And that's my key bit there, is the predictability of the improvements that are made. We're not guessing, we're modelling, we're working it out. And all hands to the pumps. Let's go. Okay.
Thank you very much, John. It's been a great conversation. Thank you for taking the time. I'm really looking forward to see what reaction we get once I get this published. See how many people's noses I've put out of joint.
Nice one. Good stuff. Thanks for your time.
Thank you, John. Speak to you soon.
Thank you for listening to my podcast mini-series, A Penny for Your Thoughts on Sustainability. I do hope you've enjoyed this episode. Like, share and follow for more episodes. Thank you.